Hello everyone, welcome back to another video, and today I'm going to be talking about the potential for a possible severe weather outbreak or even a tornado outbreak across portions of the United States during Wednesday, especially focusing in on parts of Dixie Alley, so Mississippi, Alabama, Arkansas, those kind of regions do have the potential to be seeing quite a few of strong tornadoes as well as large hail and damaging winds. And this will be quite an in-depth video, so I will be going into a fair amount of detail and that kind of thing as well. So let's get into it now. So this is the day 3 convective outlook from the Storm Prediction Center, and you can see that we have a large enhanced risk across much of this region. And when we get these enhanced or moderate risks at this kind of time period, so day 3, that generally highlights that there is a potential for quite a significant outbreak. And we can also see that the area is quite large, showing that these threats can be expected across quite a large area, but also that we do have the potential for some upgrades. So, like I just said, we do have the enhanced risk, which is level 3 out of 5, and we also have a slight risk surrounding that, which extends all the way from Georgia into parts of Oklahoma, Missouri as well. And we have a marginal risk as well, that's extending from about Kansas into kind of Georgia as well. And then we have a general thunderstorm risk around that. But like I said, we do have the potential for quite a few severe storms during Wednesday. Now this is a graphic that I made, and you can see here that we are expecting, we're expecting kind of a Pacific front or dry line, which it isn't quite a cold front, but it also is kind of it's a mix of a front and a dry line. So a dry line is when you get a boundary between much drier and much moister air, but you don't really get so much of a temperature difference. But we do actually have some evidence of a front, so we can see that we have a kind of a kink in the isobars, and we also have a bit of a wind shift as well. So that's what's kind of a mix. And then we also have lots and lots of moisture coming out of the Gulf of Mexico, and that's going to make things very unstable. And then we have this warm front, which is going to create a very large warm sector, and which does have the potential for tornadoes. There's going to be lots of instability, lots of shear, and that basically means that over such a large area, we do have the chance for quite a few tornadoes, large hail, and damaging winds. So if you look at the Storm Prediction Center's outlook, we can see here we have this enhanced risk with a 30% probability of severe weather within 25 miles of a point. And you can also see we have this black area, this black kind of hatching shading in here, which means that there is a risk of significant severe weather. So large hail, I think 2.5 inches or greater, and then wind gusts of around 75 miles an hour wind or greater, as well as EF2 plus tornadoes, so strong tornadoes. And you can see if we read here, some of the wording is quite strong. So you can see we do have lots of instabilities mentioned here, and you can see here tornado risk with the risk for a couple of significant tornadoes, as well as large hail and damaging winds. So I think there is a potential that by the time we check this tomorrow and tomorrow morning, we do have a moderate risk area in here somewhere. Right now, I'd probably say the best area for this is, if I just quickly draw out, probably something like this, what I've just drawn here. And I'm basically in the middle of the other risk, but I do think that we could definitely see an extension of these enhanced and slight risks a bit further north, kind of like this, and possibly this moved a bit further north as well. So that's what I'm possibly expecting. But now let's get it break down into the models. So this is a large scale pattern here at 500 millibars, that height level, and you can see you have this closed low. So you can see that it's closed, it's closed isobars, not kind of not kind of like a shortwave trough or a longwave trough as part of the larger flow. It's its own closed low, which is moving across parts of the United States, and you can see we have pretty strong winds at this level. And you can see that particularly in this area we have what the winds are called at diverging at upper levels. That means that they're spreading apart like this, and divergence at upper levels, it encourages lift, and it's quite a big supporting factor for deepening and formation of a low pressure system at the surface. And if I can just draw out the square here, in the most kind of at-risk region, if I just draw in this kind of box right here, that's the region. Now that's most favourable for the formation of a low pressure system. And that's why we're expecting a surface low to develop in this area during Wednesday, and that's going to have those fronts, that very large warm sector, supportive of lots and lots of storms. So the upper level pattern already favours this severe weather. And now let's get a bit closer down to the ground. So looking at the next level down, which is about 850 millibars, so kind of 1.5 kilometers, you can see here that that we have, this is basically showing the low level winds in association with this storm. And you can see we have that upper level low there. We have quite strong flow on the north west side, but also notice we have a bit of this low level jet developing across parts of Alabama, Mississippi, Tennessee as well. And that's because of basically frictional differences between the sky and the land that basically develops, and that really gives things a kick. It strengthens the wind profiles. It makes it more favourable for tornadoes because it increases the shear. And you can see that here, if I go to severe weather and I show you the shear, you can see that that really starts to increase where those stronger upper level winds are. So I'm going to go zoom in a bit more now, and I'm going to start by showing you the kind of the surface pattern, so dew points, which is the temperature at which the air becomes saturated. And you can see if we run through this loop, we have lots and lots of moisture basically just sitting in the Gulf of Mexico, waiting to be pushed northwards. And if I'm just trying to get the pen out, it doesn't seem to be working. Basically we have all this moisture in this general region. You can see here, so 70 Fahrenheit dew points, that's around 20 degrees, and where we've got those blues, that's basically 60 Fahrenheit, so around 15 degrees. So generally we have lots of this moisture basically pooling in the Gulf of Mexico, and it's basically just waiting for a low pressure system to develop, like I was talking about just back there. It's basically just waiting for a low pressure system to develop, and in response to basically drag up strong moisture return from the Gulf of Mexico. And like I was just discussing, that low level jet, that is going to help with the moisture flow into these regions. And you notice this line advances northwards into these areas and makes a large moist warm sector by the time that we go through Wednesday. And it really prepares the environment for severe storms, as you can see like this. And you can see that moisture surges more north, and like I was talking about, we get that sorry, didn't mean to press that. We get the mass responsive moisture drawn northwards as we get that low pressure system developing like this. And so we have the moisture, and that basically leads to lots of instability. And if I just show you the instability, so if I go through, I'm just going to go for the most unstable cape for now, and that's basically showing you the most unstable basically pass or layer in the whole atmosphere. So it kind of gives you an idea of where the most like instability is, and so not where, like how much the most instability is. And generally for tornadoes, it's not going to be as much as this, but still basically just gives you an idea. And if you can see that through Wednesday we get this cape really developing like this, and if I just run it through, you can see you can see we really get this cape starting to develop. This is through Tuesday, and then through Wednesday you can really see it really gets fired up, and it goes pretty far north, and we get those pockets of quite high cape before, during Wednesday evening and afternoon, we get the highest instability really maximized through parts of Arkansas, Louisiana, Mississippi and Alabama, Tennessee as well, also into parts of Georgia. And what I was talking about, this very large area of instability is going to provide a very favorable environment for severe storms. And you can see that we're getting almost up to 2,500 2,500 joules per kilogram of cape. So it does really look like we could see a pretty unstable warm sector. And then again, it does look like we're also going to be at the same time not a lot of capping, or not a lot of and there's not really like a lid on any of this convection. So that means that basically it'll be free to develop, and you can see there's no colors here. So basically there's going to be nothing stopping any storms that form. Just having a quick look at what's called the Lcl height, which is called the level the listed condensation level, and that basically is where the cloud bases are, and it's also where the air becomes saturated, so where the air meets its dew point temperature. And you can see that basically, if I run this through, we can see that during Wednesday evening, they are very low. And you might think, well, what have cloud bases got to do with anything about tornadoes? And basically, two things. So the first thing is, kind of logically, the closer the cloud is to the ground, then the easier it is for a tornado, and especially strong tornadoes, to form. But also, because of moisture, generally the higher the cloud base is, that generally means that the downdraft is a lot stronger, and that basically means the storm is outflow dominant, and it kind of reduces the tornado potential. But if you have a lower LCL, that generally means that the storm won't be as outflow dominant, and you basically get that perfect balance between inflow and the RFD outflow, which really has been shown to help the process of tornado genesis. And so basically, these very low cloud bases, not below 1,000 meters, will be favorable for tornadoes. Now, I've talked a lot about instability, cloud bases. Now we're going to talk about shear. And I mean, if I'm completely honest, the shear isn't the worst thing I've ever seen. Like, I'd say that the shear in the Easter outbreak last year was a lot worse than this, but still, we've got lots and lots of strong winds aloft, and basically that's leading to lots and lots of shear. Now, this is bulk shear, and it's the way that you can measure it on a hodograph, which I'm about to look at, is the difference between is basically the length of the vector between the 0 kilometers and the 6 kilometer wind, and it's pretty complex to explain in words, but I'll show you in a minute. But you can see that all across this warm sector region, we have these purple colors, even touching on reds in places, and that's basically showing that there's going to be definitely a supercellular mode. So any storms that do develop will be supercells, basically without a doubt. And if I just show you the helicity, which is kind of a way of saying, like, it's basically a way of measuring how the potential that the storm has to rotate, and especially in the 0 to 1 kilometer layer, that basically shows you the potential for tornadoes. And you can see that the helicity is really pretty strong across this region. Generally, kind of 200 0 to 1 kilometer helicity is generally enough for tornadoes and strong tornadoes, and you can see that in some areas, especially further north, we do have definitely more than that. And as the low-level jet strengthens during the night time, then we will get that strengthening shear, and it will become even more favorable for tornadoes. And if I show you basically something that sums this all up with a significant tornado parameter, basically we can see that I have these really bright colors on this map, basically showing that we have the tornado threat maximized in this region, and any storm that manages to stay isolated or discrete and tracks through this environment will have a good potential of producing strong, possibly even violent tornadoes. And if I just quickly show you the forecasted radar at this time, you can see that basically we have this. We basically have this, and you can see here is we basically just have isolated, discrete supercells in the open warm sector like this, and basically with all that shear, that basically means that these will just go and produce possibly loads of nodes of tornadoes. And this model that I'm using called the NAM basically really always favors a linear mode, so storms in a line like this, and to have it showing basically isolated, discrete supercell storms like this that's pretty rare. And if I just show you the HRR model but that basically just came in from this evening, basically shows the same thing, that we have this very large uncapped, unstable warm sector, and this model actually shows it up to 3,000 joules per kilogram of CAPE, and basically we get these storms here firing up, then becoming powerful supercells and basically dropping loads of tornadoes. So it does look pretty favorable that we could see this. And I mean, the trends have been really pretty consistent for this in basically the last almost 2 weeks. So it's not like it's something that just suddenly appeared. The trends have been pretty consistent, and that's why I don't really think it's going to suddenly back out at the last minute. Now, before I go, I'm going to quickly show some photographs, which is basically kind of a 3D representation of the atmosphere, and it's probably the most useful tool for forecasting tornadoes and severe thunderstorms. And you can see here that I'll just click on one near this supercell in the open warm sector, and you can see here that basically everything here is pretty favorable. The first thing I'm going to point out is that we have this particularly dangerous situation tornado. That basically shows you a possibility of what could happen. But now I'm going to kind of go into it a bit more. So what we see here is we have this but this area between this white line here and this red line, which is the temperature, that is instability. And you can see that we have lots and lots of instability through this layer. And generally, you kind of want there to be, you don't want it to be really thin and spread out between the whole thing. You kind of want it to be kind of fat. And you can see here that we have kind of that fat instability. So that does show you that we have the potential for strong, robust, and quick updrafts. And also another thing to note, very high cloud tops here at 12 kilometers, and so that really is going to kind of help any hail development, and just shows that the strength of those storms will be quite intense. And then also those LCLs I was talking about, you can see very low there below 1 kilometer, which is generally kind of the rule for strong tornadoes, but it can still happen above that. And then looking at the photograph, by the way, bulk shear is kind of, so the difference between this by the 0 kilometer wind and the 6 kilometer wind, and if you draw a line between those, that's a vector like this, and the length of that vector is what the bulk shear is. So probably around 50 here, that kind of thing. That's the way that I can tell. But generally, you can see here that we have lots and lots of good curvature in this photograph. In the 0 to 3 kilometer layer, that's the most crucial layer for tornado development and low level rotation. You can see we have lots of curvature like this, and that this area between this this kind of blue line and this red line is basically the helicity, and it's a bit low here. There have been some much better soundings representing this, but it does look like we're going to have a lot of that helicity as well. And also another thing to note is that the right moving storm motion vector, which is here, that is to the right of the line, and then it's to the right of the line that shows basically streamwise vorticity, which is basically quite a useful tool for figuring out if tornadoes will form or not. And because it's to the right of that or not on the line, that basically means that there is some of it, and that basically shows that the chances for tornadoes are kind of high. Now I'm going to stop with the video there because I've been talking for quite a long time and in quite a lot of detail, but I really hope that you enjoyed it. But overall, this does have the potential to be quite a potent severe weather outbreak, so it is important to stay up to date with this, as if you're living in the areas where it could hit, so Mississippi, Alabama, Tennessee, Missouri, Arkansas, that kind of place, and it's really important that you stay up to date with the warnings, the watches, so if a tornado does come near your house or where you live or where you're at, you can prepare for it and be safe. Thank you for watching, everyone. Good night.